My name is Gianni, and I'm making this series to document the experience of building my backyard workshop. To best show the process, I'll be jumping back and forth between real footage and animations of the model I created to help plan my build. This is the result of 6 months of planning, followed by 10 months of building. And besides the concrete, we did all of this ourselves on nights, weekends, and holidays. I'm going to cover the cost for each phase, the quantities of materials I used, and as many details about the process as I can. This new space will be fully finished with power, fiber internet, and climate control, and it will be used as a home office as well as a studio for my small business. I'm self-taught with almost every part of this project, and I hope this series will be helpful to others who are looking to do something similar. Before starting on the workshop, we had to prep an area of the backyard by removing an existing shed. It would have been nice to use this as the structure, but unfortunately it had extensive insect damage and was located right up against the property line. We decided it would be a better investment to start with a clean slate and build something a little bit larger. I began by choosing a size of 12 by 18 feet and locating it here within a relatively flat area of our backyard. Next, I began to sketch out some ideas for the entrance and window locations before selecting the following. 4 large windows provide plenty of light while still reserving wall space for tool storage. A centrally located French door to help with moving large items in and out. This symmetric design also gives me some flexibility in how I choose to place the tables and equipment later on. The building will be fully conditioned for year-round use. It has a 90 amp sub-panel that will be fed from the home along with fiber internet. Both will run to the shop in buried conduit. Since we're already bringing in new concrete for the foundation, we decided to take this opportunity and also extend our driveway back to the new workshop. In September of 2023, we started reaching out to contractors for the concrete work. We received 3 quotes back. The first was $10,050, the second was $7,659, and the last was $12,397. We decided to go with the first quote because they were willing to provide the most information to us up front. They put together a detailed drawing for our project, along with a well-written contract that gave us peace of mind. And here's the result of their first day of work. The forms were fully installed, along with a moisture barrier and rebar for the shop foundation. I had already pulled permits for the project, so at this point, I called in our first inspection with the county. The next morning, the inspector dropped by to take a look at the formwork, and they quickly signed off, and we were able to schedule our pour for later that afternoon. Here you can see them putting a smooth finish on the shop foundation. This is going to be the floor and the final space, and we wanted something that was going to be easy to seal and clean. The rest of the concrete will just have a brushed finish. I tried to keep the slab well watered for the first 24 hours in an attempt to reduce any cracking. And the following day, the crew returned to remove forms and saw cut a control joint in the center of our slab. With the foundation finished, let's take a more detailed look at the design for the workshop. With this being my first project of this size, I spent a lot of time drawing all the details in AutoCAD, and then eventually Blender, which is where this animation comes from. The walls will be a typical 2x4 construction with studs 16 inches on center. And we'll clad the exterior with zip system sheathing and place a gable roof on top to help match the architecture of our home. A structural ridge beam will allow us to have a vaulted ceiling in the finished shop, and the roof will be unvented with closed cell spray foam to protect it from moisture. Zip tape to seal all the sheathing gaps, roof trim, and a 26 gauge metal roof. Windows and doors will finally get our structure dried in before installing our trim and our hardy board siding. Finally, we'll paint the shop a maroon to match the brick of our home. Using the finished design, I was able to put together the list of framing lumber I would need to purchase. After allowing the concrete to cure for a week, I placed that order and had all the items delivered to the end of our driveway. These large LVLs are going to be the ridge beams for the roof structure. The total for all this lumber came in at $2,753. We're going to start with the back wall, which is the most simple since it doesn't have any windows or doors. The wall is 18 feet long with studs spaced 16 inches on center, and each stud is 93 inches in length. It's all standard 2x4 framing lumber except for the sill plate, which is pressure treated for better moisture resistance. For hardware, I'm using 3.5 inch 16 penny nails along with the pneumatic framing nailer. The next wall has both windows and doors, so we're going to need to use king studs, headers, and trimmers. These all work together to help distribute the load out and around the wall openings. For the front windows, we have a 4-foot wide opening, and I use 2x6s to build the headers. We sandwich a 1/2 inch thick piece of plywood between the boards, so our header will match the thickness of the 2x4 wall. The door header spans a wider gap of 72 inches, so we'll use a 2x12 for its construction. Each end wall is identical with one window and double king studs to help carry the load down from the roof's ridge beam. More on that in a few minutes. The side windows are only 2 feet wide, so we can get away with 2x4s for these headers. With all 4 walls up, we add a second top plate which helps tie everything together. The structure for this shop needs to be mounted to the foundation, so I'm going to be drilling through the sill plate and adding 8-inch anchor bolts down into the concrete. To satisfy my local code, each wall needs to have at least 2 anchors, with anchors placed no more than 6 feet apart. Each corner also needs an anchor to be located within 12 inches on one side. Now for the wall sheathing. I used the same 3.5 inch framing nails from earlier and made sure to nail every 6 inches along the sheet edge and every 12 inches on intermediate supports. With the walls in place, we can start framing out the roof. Both ends are going to have this notch that is going to support the ridge beam. There's no way I was going to be able to do this part alone, and I'm really fortunate to have a couple friends who are willing to donate a Saturday morning. Thinking ahead, we installed the rafter hangers while the beam was still on the ground, and then lifted them into place one at a time. The second beam was a tight fit and needed to be hammered from the end in order to get it into its final position. For a typical roof, the sidewalls are going to be carrying the weight of the structure, and if we place a load on that roof, the ridge sags and we push out on those sidewalls. Ceiling joists and collar ties will counteract this outward force, or we can use a structural ridge beam to prevent sagging at the ridge in the first place. This beam is supported at the gable end walls using a post and double king studs from earlier. While it's a little bit more work in engineering, this design will allow us to vault the ceiling inside of the shop. These gable extensions provide a 12-inch overhang on the end walls. I built them on the ground first and then clamped them in place for nailing. All of the rafter ends are tied together using this 2x6 before we mount the fascia board. Now we can start installing the roof sheathing. It gets the same nailing pattern as what we used on the wall sheathing earlier. It's another heavy part of the build, and I'm glad my parents made a quick trip to give me a hand. My local code allows the shop to be 3 feet from the property edge, which is great for maximizing the rest of my backyard, but it did make it a little sketchy trying to access this part of the roof. To avoid climbing that side, we decided to go up and over the top with some of the last pieces of sheathing. The zip system sheathing was pretty decent for grip, but I still wanted to screw in some 2x4 steps to help with getting around up here. And I got the zip tape rolled just in time for some winter rain. I've already added the hardy trim to the roof eaves, but now it's time to finish trimming the rakes. Instead of trying to get measurements up in the air, I'm putting together some temporary brackets to hold the trim in place while I mark exactly where I need to make my cuts. I'm using 1 by 5.5 inch hardy trim for these boards. Each board is 12 feet long, and I ordered 8 from Home Depot for $360. I'll prime and paint these boards before I get them up on the shed. The eave trim is already installed, so I'm painting that on the ladder, but it's fairly easy to get to. For paint, I'm doing 2 coats of iron ore by Sherwin-Williams. Before installing the metal roof, I decided to put together a simple roof ladder using some leftover 2x4s from the framing. This made it much easier to access that far side of the roof, and it hinges in the middle so I could simply push it up onto the roof until it fell into place. I then placed an order for the following items and received them in about a week from a local supplier. Here you can see me just pre-drilling all of the panels for their eventual mounting hardware. This roof order totaled about $980. First, we'll mount the drip edge and secure it using some roofing nails. Next, we'll add these inside closure strips. They mount with an adhesive back and seal our roof panels against that drip edge. And then I secure the panels using fasteners that are painted to match the roofing color. The last panel was just barely too wide and needed a little bit trimmed off the edge. These ends get covered by sections of gable trim, and we mount them using the same roofing hardware. I'm not going to have a vented roof, so I'm fully sealing the assembly here at the top. First, I'm adding some outside closure strips, and I'm using a piece of ridge cap to get the spacing right for those. I'll add some butyl tape on top of my closure strips to help get a good seal, and then we'll finish the roof off using the ridge cap and the last of our fasteners. The finished space is going to be fully conditioned, so I decided to go with some simple picture windows for this build. Placing a bead of caulk around 3 sides of the window flange, and then fastening with roofing nails. The bottom flange is going to be left unsealed, and this provides an escape route in the off chance some water works its way behind the window flange. These windows are 2 feet wide and 4 feet tall for the end walls, and I'm using 4 foot wide and 3 foot tall windows for the front of the shop. These 4 windows were purchased from Lowe's for a total of $1,268. The French door was a Home Depot purchase for $726. Some more help from a friend, and we had the building dried in. At this point, I could finally stop worrying about the rain, but I still needed to add some protection where the wall meets the concrete outside. I got this idea from a Matt Reisinger video on flashing concrete to framing. I'm cutting a groove in the concrete using an angle grinder all the way along the perimeter of the frame. And then I'm adding some construction sealant into that groove. After this, I drop in some metal flashing to embed that in the sealant. Some roofing nails to hold this all in place. And then another bead of sealant to finish filling in that concrete groove. Lastly, I'm using some zip tape to prevent water from getting in behind the metal flashing. We're cutting up some cedar boards for our soffit, and you can also see that the shop has outlets at this point. Installing the electric was a huge project on its own, and I think that topic deserves its own dedicated video. I pulled permits, completed all the work myself, and I was able to pass my electrical inspection on the first go around. So that'll be the next episode in this series, and make sure you stay tuned for that one. Back to the soffit, I'm using a 1/4 inch tongue and groove cedar product from Home Depot. I'm nailing these to the roof rafters using 18 gauge stainless steel brad nails. The boards came in packs of 6, and I ended up using 8 packs for a total of $216. Sticking with Hardy products for the rest of the exterior, I purchased 85 planks of 7 1/4 inch by 12 foot fiber cement siding and 16 boards for trim that measured 1 inch by 3.5 inch by 12 feet. Here I'm using a 16 gauge finish nailer to mount all of that edge trim. For the siding, I had to add a small starter strip that would give the first row something to rest against. And I'm using a siding nailer for this along with 2.5 inch galvanized nails. Once you have the first row in place, this gets pretty simple using the gecko gauges. They clip to the previous board and hold the new piece in the correct spot while you nail all the way across all of those studs. Here I am trimming the siding to fit around an exterior outlet. I'm adding joint flashing sheets behind any gaps in the planks. This was mostly only something I had to do on the back wall, since it's 18 feet wide without any windows or doors to break up that distance. And here we are finishing the siding with just one extra piece remaining. These boards are already primed, so we get to skip that step and go straight to paint. I'm going to be sticking with the same color we used on the roofing trim, Iron Ore by Sherwin-Williams. This siding paint is also a Sherwin-Williams product called Marooned, and we're adding 3 coats of it to each wall. here's the finished exterior for the shop. Thank you for watching, and be sure to check out the next videos on the electric, as well as the video dedicated to finishing out the interior of the workshop.